Today I'm introducing a topic called the Lambert W function, which is used for solving equations of the form x times e to the x equals a, where the solution would be given as x equals the W function of a. If you came from the YouTube short, I've already shown in a really basic form why this is necessary, as you cannot isolate x when it is in this form. W function cannot be expressed using fundamental operations, leading to most of its results often being transcendental, meaning they have to be computed numerically. So with this equation, this one is slightly harder than the previous one, as it's not immediately in the correct form to apply the Lambert W function. So first, you would take this and get it into exponential form, and your next steps can be a variety of things depending on the question, but what your goal should be is to approach the form y e to the y on one of the sides, which brings us to x plus 3 e to the minus x plus 3 ln 5, which isn't exactly the correct form yet, but when multiplied by negative natural log of 5, you get the correct form. And it's at this point you can make a substitution of y equals minus x plus 3, close bracket, natural log of 5, and apply our special Lambert W function. This gives that y is equal to the Lambert W of minus the natural log of 5 times 5 to the minus 3. You then substitute this back into what y equals, and we find that x is equal to the Lambert W function of negative the natural log of 5 times 5 to the power minus 3 all over natural log of 5 minus 3. So, one final thing before I end the video, I was doing some graph sketching and came across the graph of the natural log of the modulus of x plus 1 over x. And I knew the graph. After taking a few derivatives, I had figured out that the graph was roughly of this shape up here. However, before I could consider my sketch complete, I needed to know what that intersection point was with the x-axis. So, since I knew it was negative, I could plug a negative value of x in to give our equation natural log of x minus 1 over x is equal to 0. I then rearrange this into the correct form to apply the Lambert W function. I substituted y equals x to the minus 1, meaning that y equals the Lambert W of 1 equals our substituted value of x to the minus 1. Now, you might notice that I've drawn a very nice little omega here, and that is because omega is the golden ratio of the exponentials. So what it represents is omega times e to the omega is equal to 1, which makes it very handy for all sorts of things. And since we're dealing with the negative side of the graph, and we plug that in originally, we can take it as negative x to the minus 1 equals omega. Simplifying that down, x equals minus 1 over omega. However, had x been in this little extra range, this little intersection just here, Lambert W of x has two real solutions. And this is about the limit of my knowledge, so I can't actually explain to you why that is. However, this was just a nice little problem where it happened to come in very useful, and that is it for this video.